Thank you, everybody, and welcome to my presentation titled The Next Generation for Rotary Screen Printed Electronics. My name is Tom Overgoor. I'm the product manager at SPGPrints, and within my product portfolio, there's everything that is not related to textile printing. If you look at SPGPrints, we have our heritage in the textile printing. We previously were called Stork, and we invented the rotary screen printing technology. First for textile printing, but later we found out there are many other applications that can be printed with rotary screens. So we went from wallpaper to security prints to label print, and now we also are in the printed electronic space. We are still active in all of these markets, so quite diverse, and we supply both the machines and equipment for these printing solutions. We have 10 operating companies worldwide. Originally, everywhere where textile was located, we have an office, and next to that we work with an extensive sales and agents distributor network and over 1,000 colleagues. But for now, we are focusing on making prints work, whether they are tags or RFID antennas, battery management systems, solar panels, or biosensors. We've seen most of these coming by, and most of these we were able to print rotary screen. It also adds up to the previous presentation. It is for the high volume print. So previously we had some numbers which shown the range of magnitude we are looking at. Compared to other printing techniques, there are several ways to make printing work. If you look at flexographic, you have ink on raised surfaces. Rotographic, you would put inks on cavities, or you can have offset printing that is on a design on a printing plate. We are looking at the screen printing technology, so that is pushing paste through a mesh. And then you can see you can get much higher surfaces at a relative high throughput. So what are the typical demands in printed electronics? That is low resistance, but with a high laydown, and narrow line width, which can be done with a high resolution. And then coming back to the previous slide, if you would compare the flatbed screen versus a rotary screen, there are some differences, but these are quite similar. To compare these, I've included some graphics. On the left, you see a flatbed screen which prints a design. So you would have a mesh that is in a frame. You input ink on that, and with a squeegee in a linear motion, you push it through the mesh. For rotary screen printing, the principle is quite the same. But here the mesh is in a round, which also enables it to be able to print a continuous design. The squeegee is inserted inside the mesh as well as the ink, and by turning the mesh, you push down the ink through the mesh onto the substrate. If you then look on what the production scale is, we see that partners and customers often try products and prototypes on a flatbed production method. But as they size up and they get more volume into the prints, you see that rotary screen printing is more suitable. If the production capacity requires a higher capacity, the acceptable cost per print, of course, goes down. To summarize that with a short case study, I have taken a biosensor producer facing the challenge, and the print itself was not that difficult, but with 2 ink types in a register, creating a line thickness of around 400 micron and a line height of 4 micron, as close together as possible and as fast as possible. And the design being endless, that was a very nice benefit. We achieved to print this, but if you compare it to the current sheet fed production method, they were able to triple their production capacity and almost cut